Okay, so looking at compound angles again, today we're going to look at the tan x plus y. Yesterday we looked at sine and cos, and we talked about the plus and the minus. I'm actually going to derive the tan one because we know that tan is sine over cos. So if we know that tan is sine over cos, we can use the addition formulas for both sine and cos on sine over cos. Okay, so when we're looking at this, the unique thing about this, and this is not something that I would expect you to intuitively know, is that if we divide both the top and the bottom by cos x cos y, it's going to make it significantly simpler. So really I'm doing each term by cos x cos y, and it looks a lot nicer when we actually divide it all out, that it looks like this. So we've got our tan x there, we've got 1, we've got 1, we've got tan x, or sorry, tan y, we've got 1, 1, and then x and y for our tan terms. Okay, so when we put it all together, we get tan x plus tan y over 1 minus tan x tan y. Now we can do a similar calculation for the minus, but I'm just going to give it to you. It's just tan x minus tan y, so same as this one. And then we have a plus on the bottom instead of a minus. And it works out the exact same way. When we're looking at double angle formulas, now a double angle formula, all that means is x and y are equal to the same thing. So let's just say x is, or y is equal to x. So when I look at that, we get something like this, where we have sine x, cos x, sine x. Really, all that is 2 sine x cos x, because they're both the same thing. We can rearrange these, and they'd be exactly the same. Now cos 2x is a little bit different. There's actually 3 versions of it. So cos 2x, we're going to do the exact same thing. We're putting in 2x's. That should be an x. And so this should be an x right here. Oh, why is that not right? No, it's not. It doesn't want to write for me. This should be an x, and this should be an x. So those should not be y's. It should be cos squared x and sine squared x. And we know using our Pythagorean identity that we can switch things around a little bit, so I can get something like this, where I make the sine squared x as 1 minus cos squared, or like this, where I make the cos squared 1 minus sine squared, and then all I've done is literally collected like terms. Okay, so we have 3 formulas, and then again, the tan one, rather than making you derive this one, I'm just going to give it to you, so tan 2x is equal to this, and this would be making your sine and coses again. Looking at some questions, if I look at this and I want to simplify it, I can recognize that that's sine and that's the cos. It's just a matter of what version of cos 2x do you want to use. So when I'm doing this, I'm going to use the 1 minus sine squared, and then it's going to simplify things a lot, because we get 1 minus 1, we get negative 2 sine on the bottom, and we still have that sine on the top, but I can actually now cancel this stuff out. So the sine and the squared are going to cancel out, and we get 1 minus cos, which is negative cotangent. Or sorry, not 1 minus cos, that's cos over sine, and that's negative cotangent. You can use the other versions, and you'll get a simpler version using tan, but you're going to have a couple of other terms left. This is kind of the simplest way of doing it. I wouldn't expect you to necessarily get to this, but you should be attempting to get down to one term. Now, these ones are a little bit harder. I'm going to do the first 2 and leave the second 2 for you guys to try on your own, and I'll take them up on class on Friday. We're not going to have a challenge question tomorrow. Luke, quiet. That's my son just making noises. So recall that we've got sine 2x is equal to 2 sine x cos x. So when we're working with that, if we've got that formula, we know that we can change 7 times 2 sine x cos x. And that's actually just going to give us 7 times sine 2x. Same thing can happen over here. It's a little bit different. What we have to recognize is that this is sine 2x again, but our x is actually equal to 3x here. It's not just equal to x. So we've got sine 2x, and then when I multiply 2 and 3, I get 6. Okay, again, I want you to try the other 2 on your own. Same thing here. I'm going to do the first one. I'll get you guys to try this one on your own. So expand using double formula. So I'm going to use the sine 2x formula. I need to recognize that I need to divide that 6 by 2. And I actually need to bring the 5 out altogether. So it's going to be 5 times 2 sine 3x cos 3x. And we get 10 sine 3x cos 3x. Again, I want you to try the tan one by yourself, and I want you to give these two a shot on your own, and we'll take them up on Friday. The formula sheet, or sorry, the question sheets are on my desk if you didn't get them from yesterday.